To be honest, I planned to call this talk just Introduction to Three.js, but then Dominic told me that's kind of boring, so I changed it to Creating a Matrix, which sounds super cool. Okay, so I'm Stephan Schober. I work at Rumor on the other side, down there, second floor, third floor. And yeah, I'm going to show you what I've been doing since 1 year ago when I switched from Android to JavaScript. And that's Three.js. So what is Three.js? Three.js is basically a framework on top of WebGL, which means no plugins are needed. You can use it anywhere, every browser. And you're just writing plain JavaScript. There are a lot of typings also for Three.js, so you could use also TypeScript. And it's open source. For example, I think Google is using it in their latest model view, it's called, to visualize 3D content. Okay, then let's start with the basics. Just a quick question, who of you have once worked with 3D frameworks like OpenGL or WebGL? Okay, quite a few. And who has used Three.js? Okay. So let's start with some 3D basics. What we have in the 3D world is a scene, a camera, a renderer, some objects and meshes, and lights. Those are the parts we need. So let's start with the scene. A scene is basically the environment. For example, this room, and then you put objects in it and also lights, because otherwise it would be just dark. And as you can see here, it's a best example for a basic scene. Just two persons, two chairs, one table, and a TV. And how would that look like when we are creating it in Three.js? So we're just creating a new scene by calling the constructor, and then, for example, we can set the background by setting it plain white. And what we do, we will now create a Three.js example, and those are also parts of this example, and I show you the whole example at the end of the presentation. So part by part. Then there is also a camera. We have different types of cameras. A 2D camera, for example, also called an orthographic camera, and a 3D camera, which is also called perspective camera. And the most important parts of a perspective camera is the field of view. That's how wide or narrow it is, how much of the scene you see. For example, if you have a fisheye lens on a camera, that would be quite a big field of view. And then you have the aspect ratio. It's the part of the scene you see and how it is rendered. For example, 4:3 or 16:9 or some portrait landscape, whatever you want. And then you have a near clipping plane and a far clipping plane, and everything in between will be rendered. That's also quite easy in Three.js. You're just creating a camera, setting the field of view is the first parameter. Then you set the aspect ratio. For example, when you have the full window as your canvas, you would just use the window inner width divided by window inner height. And also in Three.js, every coordinate is 1 meter. So one value, one unit is 1 meter. For example, in this case, we are setting the near clipping plane to 10 centimeters and the far clipping plane to 10 meters. And Three.js is using right-hand y-up coordinate system. It looks like this. So we have x, y, and z. And this case, we're setting the position of the camera 2 meters closer to us. Next thing is the renderer. It renders and displays the scene from the camera perspective, which is defined. And it renders it to a HTML canvas element. And it does this by using the render pipeline, which means different shaders and so on. And we'll see this later. And yeah, how do we do this? We're creating a new WebGL render instance. You can pass some options. In this example, we'll just use anti-aliasing, set just anti-aliasing to true. And we also need to set the size of the renderer, which is the height and the width of the window again. And then, easy as that, we have in our example, no HTML elements really on the side, so we're just setting appending just the canvas, which we get from the renderer, as the only child of the body. So now we know how we render stuff, but we have to do this not just once, but periodically. So we have to call the render function, which is basically a function which we pass to window request animation frame, which means it's called periodically. Maybe you have used request animation frame for other types of animations on the site already. And the FPS rate you get is basically the execution time of this function you pass into the request animation frame, which means when you do a lot of stuff in this function, your FPS, your frame rate will drop down. And normally the upper frame limit you have is determined by the browser, which is also depending on the hardware. For example, on this notebook I get about 60 frames. I think it's limited to 60 frames in Chrome, and on some gaming PC it's limited to 120 frames. So it depends on the hardware. So for example, we have this function animate, and what we do is we just call it again and again. And every time we do this, we want our mesh, which we don't have yet, but we'll come to that. We will rotate the X and the Y axis a little bit. And then we call the renderer and say to the renderer, just render the scene we created with this camera, meaning that camera perspective we already defined. And then we'll do this over and over. And yeah, for example, this is a very simple render function, which means we will probably get 60 FPS, which should not be a problem in this case. So what is an object or a mesh? It's defined by a geometry. For example, you can define geometry by yourself, which you probably don't need as a beginner. So you can just use the predefined geometries like box geometry or sphere geometry, plane geometry if you want that. And a geometry has polygons. You can see this on this rabbit. The more polygons, the more round or better looking the mesh gets. And then you have the material, which can be a texture. For example, yeah, this wall has a texture, or the ceiling has a texture, or you can just say it's a plain color, like this wall, just white, for example. And they can define a lot of parameters, like how transparent it is, and so on. Okay, then let's go. Let's see how we create an object in Three.js. We're just creating a new material, in this case a mesh func material. There are different types of materials. For example, physical material, when you want to have define how rough the material is. For example, a table is more rough than a wall, and how that changes how the light is reflected in this material. In this case, we just use the Rumel red. And then we are creating a box geometry with 1 by 1 by 1, which means it's basically a cube with 1 meter. And then we create a new mesh passing the geometry and the material we already have and add it to the scene. If we would render the scene now, it would be just completely black. So we need lights to illuminate the objects within the scene. And there are different types of light. In our example, we will just use the ambient light, which means it illuminates every object in the scene by the same amount. It's not dependent on where is the light and where is the object, but we just apply the same intensity to every object. And there are also different lights, like a spotlight, which has also a field of view, and a rect area light, which is basically also a square, and it looks much different depending on which light you use. As I already mentioned, in our case, we want just to create an ambient light. It's just plain white, so it will not change the colors of our cube we already defined. And it will illuminate everything in the scene by the same amount. By default, its intensity is 1. And then we also add this light to the scene. So how does this look like? This was the whole code basically for this example. So we see our red cube, which is rotating in X and Y. And as you can see here, we have some global parameters, which we'll use in our animate function. And then we just set up the renderer, set up the camera, set up the scene, the material, also the geometry and the light. And yeah, in this case, we also add an event listener. If we change the size of the window, it will adjust. And then we have the render function. And that's it. That's how you create a 3D scene in Three.js. And as a bonus, because we called this talk Create the Matrix, and I under-delivered by now. So just this one photo, okay, yeah, lame. So what I did, I downloaded, I went to Sketchweb. Anyone knows Sketchweb? It's a website where you can upload 3D models if you're an artist, or if you can download free-to-use 3D models, and they also have quite a nice viewer. And I went to Sketchweb and downloaded some models in the GLTF format, which is a last mile format for 3D data, and I converted it to GLB, which is the binary format of the other one. And then what I did is I just used the Three.js GLTF loader to load those GLBs. And by the way, you can see all the sources I used under this URL. And then we have like this 3D scene where I downloaded the models for the 2 chairs and the table and the TV. And it's also compared to the last example, which has 53 lines of code. This one has a bit more, but not too much for what it's doing. So just 120. And you have the construct scene from the matrix. Then some small things I wanted to add at the end. There's a very nice source for, it calls itself the big list of Three.js tips and tricks, which is quite useful if you're a beginner or starting with Three.js. It would have saved me a lot of time when I found it earlier. And it explains things, how you get accurate colors, for example, when you want to model an object of the real world in 3D. So yeah, it's not that easy to get the colors right, and also some performance tips. As I already mentioned, you want to run as smoothly as possible between 30 and 60 frames per second. And also how you get rid of things, of 3D models, which you don't want to use anymore. It's called disposing. And yeah. Last thing, that's what I use it for, Three.js. At Rumor, we are creating 3D configurators and also 3D planners, so you can plan your apartment, for example, and add some furniture to it. And also we are creating a configurator where you can configure furniture online. And it looks like this at the end. So you can see it loads also quite fast. I'm super, let's try it here, if I have internet connection. Yeah, it loads quite fast, and you can change, for example, in this case, we're just changing colors on the material of the mesh. And you can also change the geometry. And in our case, add some things, so you can configure your stuff and see dimensions. Yeah, that's what we are using Three.js for at Rumor. Thanks. So, any questions? Yeah?
You download, I have no idea what GLTF and GLB are, but you download GLTF, convert it to GLB, and then load it using the GLTF loader?
Yeah, that's weird. That makes no sense. But actually, I think you can load both with the GLTF loader. It's just easier to have one file, as we heard before, instead of multiple files, because GLTF is, you have all the materials inside one folder, and yeah, and GLB is one binary file, yeah. Any other questions? Yeah?
Does it also do some kind of ray tracing when you have these beautiful balls of mirror glass and the surroundings are...
You mean, for example, here when you zoom in?
I thought of that when I saw this, yes.
No, it's, as you can see here, when you look very close, it's basically just an environment map. It's a cube, which looks like, as you define it, and so the reflection will always look like that. But you just see it when you look at it directly. If you're further away, you won't notice it, and it just looks like a good reflection. But it's not reflecting the actual scene, but always this environment map which you're giving it to it. So it's cheating, kind of. Okay, any other questions? Yeah?
Do you know any game projects which are just written with Three.js? Are they?
That's a good question. I've never checked actually, but I could imagine that there are some. Oh yeah, I think the classic Minecraft. I'm not sure if I can find it now. Yeah. Let's get there. Yeah. For example, it's the classic version of Minecraft. It's free to play. You can also play it multiplayer. And as far as I know, this uses Three.js, and it runs very smoothly. I mean, yeah, it's Minecraft, but okay. I think you had a question somewhere. No?
So, yeah. So when you are doing such an application that this configurator,
Yeah.
do you even think about how much of this is Three.js and how much of this is HTML? For example, when you plot the sizes,
Yeah.
is it inside Three.js or is it just?
The dimensions are shown directly in Three.js, yes. The interface on the left is plain HTML, and the buttons on top, but the rest is Three.js. So it depends. You could probably also show those labels in HTML if you want. You could calculate where to position them, but I think it's...
So
We decided for some reason to directly use it in the scene.
Is it a tough decision, or it's almost always obvious whether to use Three.js or HTML when you have combined logic?
It's not so easy. It depends on many factors. For example, if you want to reuse that code somewhere else, it's probably easier when you're using them directly in Three.js. For example, we are also using Unity. Additionally to Three.js, we're using it in our native apps, and we also created a WASM file, as we heard before, for a web application of. We also used Unity there, but it took too long to load, so we decided to switch to Three.js because it's much faster. And for example, when you would use Unity, then now if we, for example, want to show those labels in Unity, in our Unity configurator, you just have to develop it once, and then you can show it in the Android app, in the iOS app, and in the web application. And otherwise, you would have to create a native interface for it every time. So it's kind of an design decision where you're doing it. Okay, any other questions? Yeah?
Can you use a notebook for the record?
Sure.